What's up, folks? So I have a problem that says balls A and B of equal mass are submerged in the swimming pool as shown below, which will produce a greater buoyant force. So basically, the balls are floating in a swimming pool doing something like this. Oops, that's not really circular. Okay, cool. So we got something like this going on, right? I don't really know. You know what? Let me not even draw the water because I think that might sort of give away some of the stuff. So this is A, this is B. They said which will produce a greater buoyant force. Now straight off the bat, now you want to work as quickly but efficiently, getting the right answers as you can on the MCAT, right? I'm immediately gonna think, okay, well, what is these two balls have the same mass, right? So what could affect them here? I'm instantly gonna think volume, right? And I'm like, okay, like how can I relate volume to buoyant force? Now remember, buoyant force is given by rho v g, right? Now I see that I see that rho and g, because both of these balls are on Earth, that g is gonna stay the same. This rho, both of these balls are floating and remember, it's not the rho of the objects here, it's the rho of the fluid. That's the key. So I should write rho of fluid, right? If you think it's rho of the ball, you might be thrown off, right? Because the mass is the same, but the volume would be different, giving them a different density. So that's if you're looking at rho of the object. However, that would be wrong for the buoyant force. So I'm going to think, okay, rho of the fluid, they're both submerged in water, right? It's a swimming pool. So rho of the fluid is the same. So only, right, only the volume is going to be what determines here. So obviously I can see if this and this are constant, the only thing that would make this go up is V. So obviously the ball with the bigger volume would be what has the greater buoyant force. And I'm going to choose A in this situation. Okay? So that should be your answer, A. Thanks.